Hello genius, welcome to my YouTube channel. This is Filipino Explaining. So in this video I'm going to show you how to prove the distributive law for complex numbers. Prove that z1 into z2 plus z3 is equals to z1 z2 plus z1 z3. Solution. So I say let z be x plus I y. This is the distributive law for complex numbers, remember? So z1 will be x1 plus iy y. z2 will be x2 plus iy2. Then z3 will be x3 plus iy3. Hope you understand what I'm doing here. So this problem has two sides. Have the left hand side and the right hand side here. So we shall tackle one by one. So let's start by solving this left hand side. Left hand side, and the left hand side we are having z1 into z2 plus z3. So we just take this one and then we substitute. z1 we have it as this one, so we take this, we put it here for z2. The same case for z3. Now we have x1 plus iy1 into x2 plus iy2 plus x3 plus iy3. So let's start by working out or solving what is in the bracket. Are we there? Solving what is in the bracket. So we have x1 plus iy1 into here we just separate the real parts and the imaginary parts. So it's x2 plus x3 plus iy2 plus iy3. After that we take this, then we multiply by each term in the brackets. We take the whole of this, then we multiply by each term in brackets. So let's start. We shall start by multiplying x1 with each term in the brackets. Then after that we move to iy1, we multiply by each term in the brackets. If I say a term, I mean this is a term, this is a term, it's a term, a term. Are you there? So we take x1, we multiply by x2, we get x1, x2. We take x1, we multiply by this one, x3, it is x1, x3. We take this, we multiply by this, it is x1, iy2. We take x1, we multiply by this, it is plus x1 iy3. Then after that we take this, we do the same as we have done for x1. So we take this, we multiply by this, it is plus x2 iy1 plus x3 iy1. Hope you are getting what I'm doing here. Take this and multiply by this, we get negative y1 y2. Remember, have to remember that I times I, it is I squared. I times I is I squared, and I squared is equals to negative 1. Remember, the square root of negative 1, it is I. Meaning that if we square this, this square goes with the square root, we remain with negative 1, then I squared, it's I squared. So I squared is equals to negative 1. That's why I have taken this, this times this, I've gotten this one, and they are negative, because I times I, it's I squared. That becomes negative times a positive is a negative. This positive is a negative. Then y y1 times y2, we get this one. Are we there? This was positive, positive, it's a positive, times I squared, that is equals to -1. It becomes a negative. You get this negative, then this time this, get this. The same case for this one, because it's having an I, it's an imaginary number. So we take this, we multiply by this, we get negative y1, y3. Are we there? So at this point, or this point, we put the real parts, we separate the real parts and the imaginary parts. If I say a real part, I mean that which is not having an I, but that number that's having an I is an imaginary part of that particular number, or that term that is having an I is the imaginary part of that particular number. Are we there? Now we have x1, x2 plus x1, x3. We're done with this and this. This is having I. So we take this, these two. That's minus y1, y3, minus y1. It's y1, y2, then y1, y3. We are done. Then we take now this. We can put we can factor out I, and now into brackets we are having x1, y2 plus x1, this one, y3 plus x2, y1 plus x3, y1. We are done. So let's move to the right hand side. That's the right hand side. Right hand side, we are having z1, z2 plus z1, z3. That is z1, z2 plus z1, z3. And we have said that these are the this z1 is equivalent to this, z2 this, z3 to this one. Are we there? So we take z1 as x1 plus iy1 times x2 plus iy2 plus x1 for z1 plus iy1 times x2 plus iy, not x2 but x3, sorry, this is x3, z3, so this is x3 plus iy3. Hope you understand what I'm doing here, genius. So we shall take this, we multiply by this, then we add this times this. Are we there? So we take this x1, we multiply by x2, it's x1, x2. We take this, we multiply by this, it's plus x1 iy2. We take this, we multiply by this, we get plus x2 iy1. We take this, we multiply by this, we get a negative y1 y2. Remember this, because this and this and this I gives us I squared. That converts this positive sign into a negative sign. Are we there? We are done with this one. Let's move to this one. Plus, take this times this, x1, x3. Take this times this, plus x1, iy3. Take this times this, is plus x3, iy1. Takes this times this, negative y1, y3. Are we there? Okay. So let's separate the real parts and imaginary parts. We have x1, x2, this one. We have another one. We're done with this. We have this here. That is x1, x1, x3. Do you have another one? We have it here. Minus y1, y2. Then have this one here, minus y1 y3. You're done. You're done. So for i's, plus I, we can factor it out and say I into, have this one, x1 y2, have this, plus x2 y1, we have this one, plus x1 y3, we have this one, plus x3 y1. Okay, and we are done. We are done with this. So you can compare the two and see. This for left hand side, this for right hand side. Are they equal? Because we have been asked to prove that this is equal to this. Let's compare and see. We have, for left hand side, we have x1, x2, we have x1, x2 here. For right hand side, x1, x3 plus x1, x3. We have negative y1, y2, negative y1, y2. You have negative y1, y3, y3. You have negative y1, y3, plus I, x1, x2, x1, x2. You have x1, x3, y3. You have x1, y3. Here we have x1, y3. We have this one here. This, then this one. We have x2, y1. We have x2, y1. Then lastly we have x3, y1. We have x3, y1. As simple as that for that case. See you next time in the next video. Have a very good and nice day, a nice time. Genius, don't forget to subscribe to my YouTube channel. Bye.